Jai Hind to everyone. I, Dr. Rahul Kumar Pandey, Assistant Professor in Ajay Kumar Garg Engineering College. Today, my topic is Poisson distribution. It is very important topic in statistical techniques, and it's my fourth lecture. So, today's contains in discrete probability distribution. It's occur in discrete probability distribution. Basically, distribution has two types: discrete distributions and continuous distribution, and it's happen at theoretical probability distribution. Majorly topic is expectation distributions, all occurs in statistical techniques. Okay, now we have to discuss discrete probability distribution, and it says several types of distribution like binomial distribution, Poisson distribution, negative binomial distribution, Bernoulli distribution. Here basically distribution has occurs in summations type. So we go through in Poisson distribution. What is Poisson distribution? Before Poisson distribution, we understand as a binomial distribution, because Poisson distribution as a limiting case of binomial distribution. What is limiting case of binomial distribution? Firstly, we understood what is the binomial distribution. Binomial distribution is a distribution of repetitive natures, and it's based on trials of success, failures, pass, fail, occurrence, non-occurrence, acceptance, rejections. Okay, so basically here number of trials are repetitive natures, and it's defined as probability function of binomial distribution P of x equal to x n c r p to the power r q to the power n minus r, where P is a probability of success and Q is a probability of failure. Repetitive nature means if success is P, R times P, and Q is basically N minus R times. Why? Number of trials is N. Here number of trials is N, means probability of success is N R times, so probability of failures is N minus R times. Okay, and we all know that probability of success and probability of failure equal to 1. P plus Q equal to 1. So probability function is P of x equal to x, NCR, P to the power R, Q to the power N minus R. Here probability of success and probability of failure are equibalanced with respect to P plus Q equal to 1. Okay. So here we consider Poisson distribution, and Poisson distribution as a limiting case of binomial distribution. If the parameters n and p of binomial distribution are known, we know that n is number of trial and p is probability of success. So we can find the distribution, but in situation where n is very large and p is very small. This is main important phenomena in Poisson distribution. Here probability of success is very small in comparable of number of trials. Number of trials is very large. Okay, such that if we apply in binomial distribution in various form, so we assume n tending to infinite and p tending to 0, means n tending to very large and p tending to s compares very small, yani p tending to 0. So NP, product of these factors n and p, always remains finite. Okay, so NP equal to lambda. This is a mean of the Poisson distribution. Poisson distribution has various phenomena like mean, mode, MGF. This is main parameters. Recurrence formula for Poisson distribution. Recurrence formula. What is the recurrence formula? Recurrence formula means we have to obtain aggressive value like P1, P2, P3, P4, P5. So P equal to x of x equal to r, e power minus lambda into lambda to power r upon r factorial. It is probability functions of Poisson distribution, just like probability function of binomial distribution p of x equal to x. P of x equal to x NCR p to the power r q to the power n minus r. This is probability function of binomial distribution, and here the probability function of Poisson distribution is e to the power minus lambda to the power r upon r factorial, where lambda is product of number of trial and probability of success, which is always finite, where lambda is finite number NP. Okay, and it's represent probability distributions. Here lambda is main parameter of this distribution. Okay, and sum of all probabilities p of r equal to 0, 1, 2, 3 is 1. We know that all summation of all probability is equal to 1. मैक्सिमम वैल्यू प्रोबेबिलिटी की 1 ही होती है और मिनिमम 0. ठीक है. ओके, तो प्रोबेबिलिटी बेसिकली लाइज बिटवीन 0 to 1. नाउ रिकरेंस रिलेशन फॉर डिस्ट्रीब्यूशन p equal to r plus 1 equal to lambda of r plus 1 pr. From recurrence relation, we have to find out p1, p2, p3, p4. If putting the values of r equal to 0, 1, 2, 3, just we have to find out p1. If r equal to 0, p1. If r equal to 1, p2. If r equal to 3, p4. Application of Poisson distributions. Why use Poisson distribution? It is a very important phenomena for statistical techniques. This distribution is applied to problems concerning arrival and pattern of defective vehicles in workshop, patients in hospitals, telephone calls, demand pattern of certain spare parts, number of fragments form of the cell hitting a target, and emission of radioactive particles. Okay. These various important aspects for Poisson distribution. So it is very important in these parameters. So next, important, interesting and very likely one means measure things of probability distribution is, as last topic we have discussed, or measure of central tendency, mean, median, mode and movement in generating function. This is important phenomena for any distribution. So that here in Poisson distribution, mean is equal to lambda. Just we have to find out in previous slide. Okay, in previous slide, mean lambda equal to NP. It is a mean. It is a mean of Poisson distribution, in short form PD. Okay. So how we find out mean? So before finding out the mean, we have to consider MGF of Poisson distribution. What is MGF? MGF is a movement generating function. Movement generating function of Poisson distribution. So movement before starting the of MGF in Poisson distribution, firstly we have to understand what is MGF. MG have two types. MG have two types in discrete distribution. MGF MXT summation of e to the power tx p of x equal to x, and in Poisson distribution, sorry, Poisson nahi, okay, continuous distribution. Continuous distribution. MXT equal to integral of a to b e to the power tx f of x dx. From MGF, we have to find several movements directly. It is a procedure for finding movements directly. So we have to find mean, median, mode, standard deviation, variance, etc. It is a very effective formula for direct evaluating this one. Okay, so now from MGF of Poisson distribution, to here also we have discussed Poisson distribution is a discrete distribution. So MGF formula mxt equal to summation of e to the power tx p of x equal to x, where e of tx is kernel of this function and p of x equal to x is probability function for binomial Poisson distribution. Okay, here e to the power tx kernel and e to the power minus lambda into lambda to the power x upon x factorial probability distribution for Poisson distribution, probability functions for Poisson distribution. Okay, basically exponential taking e to the power tx into e to the power minus lambda, summation of e to the power tx minus lambda, but in the summation here lambda is a constant and x is a variable, so e to the power minus lambda बाहर कर सकते हैं and summation of lambda e to the power t whole power x upon x factorial, this function equating this function and put the value of x equal to 0, 1, 2, 3, 4. Put the value of x equal to 0, 1, 2, 3, 4 e to the power minus lambda. If putting x equal to 0, so something power 0 is 1 upon 0 factorial 1, 1, first entry 1, second entry lambda e to the power t whole power 1 upon 1 factorial, third entry lambda e to the power t whole square upon 2 factorial, lambda e to the power t 3 factorial and so on. Okay, and consider this series. This series is exponential series in lambda e to the power t. Exponential series, we all know that. What is exponential series? Exponential series is e to the power x 1 plus x upon factorial 1, x square upon factorial 2, x cube upon factorial 3, x power 4 upon factorial 4 and x power r upon factorial r and etc like infinite. Basically it is infinite series. Okay, this is series of exponential. So e to the power minus lambda and e to the power x, in place of x here lambda e to the power t. So e to the power minus lambda into e to the power lambda e t, basically adding both powers in exponential e to the power lambda of e to the power t minus 1, and this is movement generating function of binomial Poisson distribution. Poisson distribution mxt e to the power lambda e to the power t minus 1. Here I also discussed from movement generating functions we have to find out directly mean, median and standard deviation, variance. So how? This is formula for finding out movements, and formula is for VR d upon dt of r mxt at t equal to 0. This is formula for movement about origin. We all know that VR is a movement about origin, and here VR equal to dr upon dtr mxt of t equal to 0. If t equal to 1, d upon dt of mxt, and it is a movement about origin is first movement about origin. And if r equal to 2, so v2 equal to d2 upon dt square, dt square mxt at t equal to 0, its second movement about origin. Okay, a succession of v3, v4, v5, so that we have to find all movement about origin, and in terms of mean, standard deviation, yeah, variance, we have to find we have to also know that relation between movement about origin and movement about central movement. So from relation between movement about origin and movement about central movements, we have to find all these parameters. Okay. So first movement about origin V1 equal to d upon dt of mxt. To differentiate movement generating function at the first time with respect to t. With respect to t, we have to find out V1 at t equal to 0. This value is lambda, and V1 first movement about origin, we all know that it is called mean. Mean of any distribution is movement of origin first movement. Okay, we have find out here. First movement of Poisson distribution is lambda, and second movement about origin, put the value of r equal to 2, V2 equal to d2 upon dt square mxt, and differentiating mgf 2 times by product of two function of t. First function differentiate, second function constant, plus first function constant, second function differentiate, and put the value of t equal to 0. So we have to find out this value, lambda of lambda plus 1. Here all differentiation I have covered, just seen terms by terms. Okay, and put t equal to 0. So V2 equal to lambda of lambda plus 1. It is a second movement about origin, but we have to find variance, and variance is central movement, second central movement mu2. Mu2 is called variance. And how to find mu2 from V2? So we have all know that formula from relation between the movement about origin and movement about central mean is mu2 equal to V2 minus V1 square. Mu2 equal to V2 minus V1 square. V1 is first movement about origin, is also called mean or x bar. Here mu2 equal to V2 minus x bar square means first movement about origin ka whole square. Okay. Put the value of V2 and V1, and we have to find, and here we have to find out the values of mu2 in terms of lambda. So in this distribution, Poisson distributions, mean and variance are same, which is called lambda. Okay, the mean and variance are same, which is called lambda. Now, this formula also valid for finding out mean and variance from original formula in movements. You have to also consider that formulas. Now, coming to questions in Poisson distribution, what is type of questions? Just we go through. And one example, using Poisson distribution, find the probabilities that the S of the spades will drawn from a pack of well shuffled cards at least once in 104 consecutive trials. Okay, तो हमें probability find out करनी है. Before starting the lecture, before starting this question, firstly we have to understand here what is the value of n. N means trials, number of trials, and here n is 104, 104. Okay, and probability of success. What is probability of success? Here probability of success is the S of spades will be drawn a pack of well shuffled card. एक निकालना है, का निकालना हमें, ठीक है, और कितने पत्ते टोटल 52. ओके, तो प्रोबेबिलिटी ऑफ सक्सेस इज P इक्वल टू 1/52, 1/52, एंड 1/52 इन कंपेयर ऑफ 104 is very less quantity. That is main theme of Poisson distribution, main recognition of the Poisson distribution as compared to binomial distribution. What is difference between Poisson and binomial and normal? In normal distributions, probability of success and probability of failure both are equal. Okay, so here we have to find out value of mean, lambda equal to np, lambda equal to np, 104 into 1 upon 52, and here mean is 2, mean is 2. Okay, now probability PR, probability function PR, e to the power minus lambda, lambda to the power r upon r factorial. We have to know that the probability distribution function or Poisson distribution, e to the power minus lambda into lambda to the power r upon r factorial. Put the values of lambda, e to the power minus 2 to the power r upon r factorial, and find the probability. We have to find the probability that S of spares will be drawn up from pack of well shuffled cards, at least one. This important term we have to know that at least one, कम से कम एक तो आना ही चाहिए 104 में. तो 104 निकालने जाएंगे तो हालत खराब हो जाएगी. 1 2 3 4 5 6, just see P at least one S of spares means P1 plus P2 plus P3 plus dot 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 P104. This is very long process. So one interesting चीज in probability, just find out nothing means 1 minus P0, मतलब हमारे पास उसका ना निकालने की probability आप find out कर लो और total probability में से minus कर लो 1 minus P of 0. We all know that. So 1 minus P of 0 means एक भी हमने नहीं निकाले, उसके हम निकाल लेंगे 1 minus P of. अब here r equal to 0, here r equal to 0, put the value of r equal to 0, e to the power minus 2 to the power 0 upon 0 factorial. The value is 1 minus 0.135. तो एक भी कार्ड ना निकालने की प्रोबेबिलिटी है हमारी 0.135 और टोटल प्रोबेबिलिटी हमारी 1. तो 1 माइनस ऑफ 0.135, तो वैल्यू इज 0.865 फॉर प्रोबेबिलिटी एट लीस्ट 1 S ऑफ स्पेट्स. ओके, तो बशर्ते सबको निकालने से अच्छा है कि हम ना कि निकाल लें और 1 माइनस कर दें तो हमारा काम हो जाता है, तो हमारा काम हो गया. लेकिन यहां मेन इंपॉर्टेंट चीज क्या थी? लैम्डा. And procedure for finding out the lambda is lambda equal to NP, where N is number of trial, P is probability of success. That's why we have to find out lambda equal to 2 and putting the values of lambda equal to 2 in probability functions, जिससे हमें आसानी हो गई ये probability question solve करने में. Okay, it's also simple process for solving probabilities questions. Okay, now second question. A skilled typist on routine work kept a record of mistakes made per day during 300 working days. Okay, just go through. Mistakes per day 0, number of days 143 में. Mistakes per day 1, number of days 90, 2, 42, 3, 12, 4, 9, 5, 3, 6, 1. Fit a Poisson distribution to the following data. Fitting of a curve is a very important phenomenon in statistical tools. So here, how to fit a distribution from given table. So it's a very important questions. Okay. So now solution. Firstly, fitting in any distribution. Firstly, we have to find out probability function of that particular curve. Okay, and here we have also show that number of working day is 300 and number of trials means 300 and probability we have to find out. Probability as compared to 0.89 very small, so it is a Poisson distribution. Okay, so firstly we have to find mean of distribution, and here in the tabular form we all know that what is the formula of mean. In tabular form the formula of mean is summation of f into x upon summation f, where x is data, f is frequency, and summation of f frequency is also called capital N. Okay, here data is x, number of days in f, f into x, first, second, third, fourth, fifth, sixth. Okay, just adding all fx upon 300 and value is 0.89, which is very less as compared to 300. Okay, we have to find lambda. That's after required Poisson distribution and fitting of any curve. Formula is this one, n into p of x equal to x or p of r equal to r. This is a fitting of any distribution, n p of x equal to x or p of r equal to r. Okay, so here we have to take in Poisson distributions, or we have to also fit in Poisson distribution form. Required Poisson distribution is capital N into e to the power minus lambda to the power r upon r factorial. Now put the all values. N is capital 300, e to the power minus lambda is 0.89 and 0.89 to the power r upon r factorial. Just put the values of r. We have find all possible fitting tools. Now put the mistakes, means r equal to 0, frequency is 123.3, r equal to 1, frequencies probability functions is for fitting distribution 109.5, 2 48.9, 3 14.4, 4 3.3, 5 0.6 and 6.09. This all will form in decimal, okay, but in theoretical frequency we have to all take an integer. Okay, just we have to consider what is the integer. 123.3 0.5 से नीचे हो तो हम आपका नीचे वाली वैल्यू लेते हैं 123. 109.5 0.5 हो या 0.5 से ऊपर हो, ऊपर वैल्यू लेते हैं हम 110. Okay, 48.9 means 49, 14.4 means 14, 3.3 means 3, 0.6 means 1, 0.5 से ऊपर है ना, 0.09 means 0.0. So this is fitting Poisson distribution. Okay. Now next example, if the variance of Poisson distribution is 2, find the probabilities for r equal to 1, 2, 3, 4 from the recurrence relation of the Poisson distribution. Here variance of distribution is given, means mu2 is given and mu2 of Poisson distribution is lambda, which is also equal to mean. Variance of Poisson distribution is lambda equal to 2, or we have to find all probabilities, all recurrence relation for Poisson distribution, means we have to find P1, P2, P3, P4, or before starting this slide we have to also discuss recurrence relation. And what is recurrence relation of Poisson distribution is this one. P of r plus 1 equal to lambda upon r plus 1 into PR, and put the values of PR as sequential form. Put r equal to 0, put r equal to 1, put r equal to 2, put r equal to 3. So thus we have to all obtaining the values of P1, P2, P3, P4. Just put the value of r equal to 0. Here r equal to 0 to P1 equal to 2P0. And before the value of putting, we have to find P of r, e to the power minus lambda r upon r factorial. Put P of 0, so where r, put the value of 0, e to the power minus 2, lambda equal to 2, 2 to the power 0 upon 0 factorial means e to the power minus 2. Of what is the value of e to the power minus 2? So from calci, we have to find out the values of all possible exponentials. 0.1353. That's why P1 equal to 0.2706, P2 equal to 0.2706, P3 equal to 0.1804, P4 equal to 0.0902. This all possible by recurrence relation. If we have to find any succession of probabilities, any form, just like not Poisson distribution is binomial distribution, is normal distribution. If we have to find on any probability functions, so we have just put it reconciliation and you have all possibilities have just find out P1, P2, P3, P4. It's all about Poisson distribution. Okay.